Dear all, welcome to the playlist of Sensors and Transducers. In this session, I'll be discussing a resistance temperature detector. To get the previous video link, please check on the I button. Moving on to the discussion, first and the foremost, we can understand what do you mean by resistance temperature detector. A resistance temperature detector, it is also known as resistance thermometer or else you can call R.T.D. It is an electronic device used to determine the temperature by measuring the resistance of electric wire. Especially we are using platinum. Okay, platinum wires are mainly used in R.T.D. The wire is referred as temperature sensor. And also, if we want to measure the temperature with a high accuracy, an R.T.D is the ideal solution. Compared to thermistor, it shows better accuracy. You can able to observe the availability of R.T.D in a market. Like this, it's available. Okay, let us continue the discussion. The resistance increases as the temperature of the sensor increases. And also, the resistance versus temperature relationship is well known and it is repeatable over time. So these are the speciality of R.T.D. And also R.T.D is a passive device. Why? Because it requires an external source to operate. It does not produce an output on its own. That's why it is known as active transducer. External electronic devices are used to measure the resistance of the sensor by passing a small electric current through a sensor to generate a certain voltage. Anyway, that particular wire is very important. That is a sensing element. So you will be placing the sensing element within the whole system. Later on, remove that particular wire and you are going to measure the resistance. That resistance will be compared with the temperature. It is having high accuracy. Suppose if you are using a platinum wire, it shows wide range compared to other type of conductors. For example, typically 1 milliampere or less than 5 milliamp, less than that particular range. For example, 1 milliampere or less measuring current, 5 ampere is the maximum without the risk of self-heating. So you will be getting, you are actually passing the certain amount of current, say 1 milliampere or 5 milliampere, because that R.T.D is a passive element. So we require an external excitation. So up to 5 ampere you can able to pass the exciting current. Okay. So you will be measuring the resistance. That resistance will be compared with the temperature after plotting the graph. Moving on to the further discussion. Another method is R.T.D converts the temperature into electrical resistance, which can be measured by using Wheatstone's bridge. You can apply the principle of Wheatstone bridge principle, balancing principle that I will show you in the next slide. So this is the schematic diagram of R.T.D. We can able to see the glass coating, then lead wire is available. Lead wire is mainly used for calibration. That means for extending the range. And also we have the ceramic core here, and inside you can able to see the platinum wire. Okay, you can able to see the platinum wire at the bottom side, exactly inside. Okay, that platinum wire resistance will be measured with respect to change in temperature. The resistance of the platinum wire is getting varied. That resistance will be measured with the help of Wheatstone's bridge. That I will be showing in the next slide. So this is another diagram which shows, for example, either you can use thermistor or R.T.D. This is representing thermistor or R.T.D. Then you will be measuring the resistance by using any of the technique. For example, ammeter voltmeter method. That is not accurate. And you can go for Wheatstone's bridge. Likewise, there are many more methods. You can go for ohm meter. Many more methods are available. Still, you can go for multimeter. There are a lot of methods are available. However, we are going for high accuracy. That is why we will be preferring resistance temperature detector. That means for accuracy, if you are still looking on the accuracy, go ahead with the R.T.D. You can able to see the construction details of R.T.D, and we have the lead wire, intermediate lead wire. It is used for the calibration, and we have the probe body. Okay, we have the probe body. Inside you can able to see the platinum wire. See, platinum wire. Platinum wire can be seen inside. It is very clear, and metallic winding material is also there at the bottom edge. This is the outer sheet for the protection against mechanical injury, and we can able to see the platinum sensing wire also. Bottom side you can able to observe platinum sensing wire, and non-conductive insulation also available here. It is very clearly observable. So this is the basic construction details of resistance temperature detector. And also these are the R.T.D which are available in practically market. If you look at the market availability, you will be getting the observation in this manner. Okay, this is the way how it look like. So this is another diagram which is regarding R.T.D. You can have a look on this. So where is the lead wire? Lead wire is mainly used for the calibration. You can see the process connection. Thread is available here. Then 3-wire configuration. I will tell you 2-wire configuration, 3-wire configuration, why it is required. And you can see the outside diameter part, then platinum resistance element. Anyway, you are measuring the resistance of that particular platinum wire. Okay, by using any of the technique, any of the resistance measuring technique. This is very important graph regarding R.T.D. The graph shows resistance versus temperature. In fact, you are measuring the resistance of that particular platinum wire. Then you will be plotting the curve resistance with respect to temperature. This curve can be taken as a reference. You know that you can use platinum wire, copper and a nickel. However, platinum gives wide range of temperature measurement. For example, you can able to measure 500 degrees Celsius. This graph shows that platinum is better compared to other two elements. Okay. For example, at 500 degrees Celsius, you can able to measure the resistance. In case of copper, for example, at 300 degrees Celsius, you can directly measure the resistance. And also at 300 degrees Celsius, you can measure the corresponding resistance of the nickel. Okay. For likewise, corresponding temperature, there will be standard value of resistance. You have to find out based on the curve. Normally, PT100 is the most commonly used R.T.D. It's available in the market. You can check the various websites. You will be getting the information about Platinum 100. And also you can download the data sheet too. Different range you will be getting. What about the temperature range? Everything you will be getting very clearly. So this is another graph. It also shows the wide temperature measurement range of platinum. So platinum is much preferable. How do you measure the resistance? For example, you are using platinum wire. At 400 degrees Celsius, you just calculate the value of resistance. Resistance will be almost 500 ohm. Okay, that means 400 degrees Celsius. Suppose you are measuring the resistance of the platinum wire. Whenever you are measuring the resistance of platinum wire at 400 degrees Celsius, at 400 degrees Celsius, resistance must be 500 ohm. For example, at 200 degrees Celsius, what we can say, the resistance will be in between 200 and 300, say 250. You can look at here at 200. See, at 200 degrees Celsius, the resistance will be 250 ohm. Likewise, you can able to measure. Let me tell you one more thing. How do you measure the resistance? As I told you that you are using platinum wire, then corresponding temperature, the resistance of the platinum wire also getting varied. Alright. Now let me ask one thing. How do you measure the resistance? Yes, we can go for Wheatstone's bridge principle. So this is a Wheatstone's bridge. You can able to see R1, R2, R3 and you will be placing your platinum wire over here. That is why I represent it as R.T.D element. Okay. Now what you can do is you need to maintain the bridge balancing principle. You can take the ratio like once the bridge is balanced, the galvanometer or you can call voltmeter that shows zero deflection. That means bridge is balanced. Later on you can take the ratio like R1 divided by the resistance of the R.T.D element that is equal to R2 divided by R3. I know the value of R1, R2 and R3 but I do not know the value of R.T.D element. I have to calculate. We can easily calculate. That means R1 by R.T.D is equal to R2 by R3. From that you can able to calculate the unknown value. So that unknown value of resistance can be easily computed. Then that can be compared with the temperature. Clear? So this is the way how R.T.D probe look like. So this is a typical R.T.D design. You can able to see. However, you can say that platinum element, the resistive element that is most important. And in this configuration, the calibration that is also very important. And also how you are going to maintain the calibration that is also matters a lot. Okay. Now let us discuss about R.T.D configuration. What are the different R.T.D configuration? As you can observe, there are different R.T.D configuration in the slide. First one is 2-wire compensation. We are using red and white wire. This is your R.T.D element. As far as 2-wire compensation concerned, this is least accurate. If you want to go for little bit accuracy, go for 3-wire compensation. In case of 3-wire compensation, you can able to see you are using 2 red wire and 1 white wire, and you will be arranging the Wheatstone's bridge. Third wire provides the method for removing the average lead wire resistance from the sensor measurement. Thus, it ensures the accuracy. If I talk about 4-wire compensation, so 2 red wire and 2 white wire you can able to see. So this is highly accuracy. If you are still looking for high accuracy, do prefer 4-wire compensation. It is somewhat expensive, however it gives accurate value of temperature. Okay, that means you will be measuring resistance, that value can be compared with the suitable temperature. So this is known as different R.T.D configuration. Okay, from this graph we can say that 2-wire compensation, that method is least accurate compared to 4-wire compensation. Let us discuss few advantages of R.T.D. Linear over wide operating range, so that temperature measurement is totally convenient. Okay, and wide temperature compensating range. So we already learned the compensation technique. You can go for 4-wire compensation and it gives more accurate result. It shows better stability at high temperature. So that is another peculiarity. Unlike thermistor, interchangeability over wide range, that is also possible. There is no drift. Okay, drift can be avoided. Then interchangeable sensors. Then ability to measure narrow span, that is also possible. And also it is suitable for remote measurement. Okay, so these are the peculiarity, major advantages of resistance temperature detector. If I speak about certain drawbacks, let us list out few drawbacks of R.T.D. It is difficult to maintain purity at a high temperature. That is a major issue. Sensitivity is poor compared to thermistor. Slower response time compared to thermistor. That is another issue. At a low temperature, resistance is independent of temperature. You know what is positive temperature coefficient of resistance and negative temperature coefficient of resistance. However, in case of R.T.D, we are mainly using platinum. Platinum shows positive temperature coefficient of resistance, PTC. And also there are certain setback like affected by shock and vibration. That is another con. And require 3 or 4-wire compensation for better result. Otherwise, if you go for a 2-wire compensation, it is cheap, but I won't get the suitable result if I go for 2-wire compensation. It is better to go for either 3 or 4-wire compensation. Self-heating error, that is another issue. So you'll be getting wrong reading. However, it is accurate, still there is a problem of self-heating error. Suitable heat sink, all those things are need to be arranged. Susceptibility to mechanical damage, shock and vibration, mechanical damage, these will be directly influencing on the performance of R.T.D. That has to be taken care. It is not repairable, just like use and throw. No point of sensing. So these are the few setbacks of R.T.D. Okay, we have learned what are the pros and cons of R.T.D. Where does R.T.D use? It can be used in AC and refrigeration. It is one of the best application. And a food processing unit. Okay, anyway, for food processing, you have to maintain suitable amount of temperature. That has to be measured accurately. Else, there are lot of errors that will be taken place at the time of food processing. Then textile production. For that purpose also, temperature has to be measured accurately. Plastic production, then electrochemical process, and presence of catalyst, all the catalyst reaction. Temperature matters a lot. Air, gas and liquid temperature measurement, that's also possible. Let us see remaining part of the applications. Exhaust gas temperature measurement, then immersion sensor, surface mounted sensor for measuring the surface temperature. So these are the major applications of R.T.D. I have referred the following textbooks to gather the information. In this video, I have discussed about what do you mean by R.T.D, what are the constructional details of R.T.D, how does R.T.D operate, and I have shown you certain graph. How do you measure temperature by considering the resistance value. Later on I have explained how do you measure the resistance by using Wheatstone's bridge principle. You are actually, for R.T.D we require Wheatstone's bridge, and also we have to apply different compensation, 2-wire compensation, 3-wire compensation and 4-wire compensation. We found that 4-wire compensation is most accurate but little bit expensive. Thereafter I have explained what are the major advantages and disadvantages of R.T.D. Finally, I have discussed few applications of R.T.D. I hope the session is useful for you. Finally, thank you very much for watching this video. If you are having any doubts regarding the topic which I covered, you can put up in the comment box. I will revert.